Grading is one of the most common exercises in the land development industry, and for some reason, people really struggle with it. And most people want to hop right into AutoCAD Civil 3D before they actually learn how to grade by hand, which is exactly why I made this content. My goal is that after this video, you will gain a clear understanding of how to grade a road, residential lots that are all backed up to a stormwater management pond. As a bonus, I even include videos and pictures of a neighborhood to help you visualize the connection between real life and construction plans. Anyone can learn how to grade, it's everywhere around you. You just have to continue to investigate. But I'm wasting daylight here, so let's dive right into it. Let's start by looking at the site plan. Now, what I will say here is that grading should never start until you have a final site plan. Why? Because that means that your grades will change if you start changing up this cul-de-sac here, all the lots, all the ponds, all of your grades are gonna have to change. So you don't wanna begin a grading plan without a site plan. The order of operation to be an efficient civil engineering team is 1, finalize the site plan, 2, finalize the drainage model. We'll get to that in a second. And then you can begin your grading. Now here we have a road, a cul-de-sac with lots, and a pond on the back of the lots. This little squiggle here is the normal water level line. Now this is a wet detention pond. Again, we deal with a lot of wet detention ponds in Florida, but all this grading exercise will be the same even if you had a dry pond. Now the big question here is, where do I even start? How do you even start grading? Where do I start on this map? Well, we're not actually starting on this map first. The first thing that we have to understand is the set of rules. It's like a logic equation. It's a mathematical formula. So you start by understanding your list of rules. So let's review what those rules could be. Once you have your list of constraints, grading becomes way easier than you think. The hard part is actually visualizing what you're doing, but we'll get to that in a second. So let's start with our list of constraints, and this is not necessarily in order of importance, but this is where my brain heads first. And 99% of these are code driven, meaning your local municipality has a land development code or some sort of stormwater or transportation manual that you have to follow. So we're just gonna start diving into what the constraints will be. So number 1, what is the first one that I like to typically find? Well, what is the minimum low point of the road? What is the lowest point that this road could possibly be? We have to know that. Now, where do we get that? We get that from the land development code or the stormwater design manual. Now, let's just say if we were working in Hillsborough County, Florida, I happen to work in that county a lot, you would have to go through this stormwater management technical manual, and there's a lot of great information in here. And there's typically tables about how you actually set your roads. You have your design storm frequencies. I'm not going to go searching for that. I'm just going to tell you that for this example, the minimum edge of pavement grade has to be from your design high 25 elevation plus half a foot. Now, what am I meaning by that? So let's take a look at some of these lines here. So here we have a center line of the road. And these are all really good terminologies. Hopefully you guys know a little bit about these by now, but let me walk through them. So here is the edge of pavement grade, and I'm just gonna call it EOP, edge of the pavement grade. That's the edge of that asphalt. Now right here on the back, right there, that's the back of curb, and I'm just gonna say BOC, back of curb. And again, later we'll see all these pictures and videos, and I'm sure I can flash on my screen what this looks like. And then you have your sidewalk right here. It's a 5-foot sidewalk. So both of those lines right there, that is the sidewalk. And then you have that dark line right there, which is the right of way. If you don't know what right of way is, go watch my other videos. I do a lot of explanation on what a right-of-way line is. It's basically the start of someone else's property line. So we got everyone's properties over here. You really need to understand these lines because I'm going to be referencing them a lot. So what is the minimum edge of pavement? The minimum edge of pavement is going to have to be minimum our design high 25 year plus half a foot. Now, since these lanes are 12 feet wide, and I can verify that right now, disregard the 0.03, sometimes there's a scaling issue, but let's say this is 12 feet wide. Well, if my minimum edge of pavement grade is the design height 25 plus half a foot, I know that typically we slope the cross slope of the road 2%. That means my minimum center line has to be the design height 25 plus 0.74. So again, that point right there equals design height 25 plus half a foot. And again, since it slopes up to the center line or away from the center line at 2%, get out your calculator if you need it. You shouldn't need your calculator for this, but if you do 0.02 times 12, you're going up 0.24. So that's where I'm getting the 0.24. I got to add 0.24 there. So that's how I'm going to have to set this minimum crown. So here we got this road inlet here, which again is a low point from a high point all the way down there to there, and then from a high point all the way down there to there. So what are some other things? We're gonna write all these down. I'm gonna put all these in the link in my description. What else do we need? What is the minimum road slope longitudinally? We have to know what we're dealing with when we're traveling up and down this road along the PGL, or the profile grade line. That's another term that I'm going to be using a lot. So you have a profile grade line of the road, which is essentially just the center line. I need to know how steep it can go and what slopes minimum I can use for that longitudinal slope. I know that after verifying in the LDC, or the Land Development Code, that I can use a minimum 0.35%. Again, that's 0.35%, or 0.0035 foot for foot. Always remember your 2 zeros there. So now what else do we need? We need the maximum distance between road low points and high points. One thing that I'm thinking about when we're creating this site plan is where my easements are going to be. So this road is going to be collecting water into curb inlets or inlets, some sort of drainage structure in order to actually get it to the pond. Now, a good rule of thumb is around 300 feet between highs and lows. And the reason why it's 300 feet really goes with capacity of typical residential curb inlets. That's about as much area as it can handle before you start having to increase the capacity. So just verify with your jurisdiction. So as you can see though, let's verify how far away these high points and low points are spaced. And the reason why I know where these low points and high points are going to be is because I see these drainage easements. These right here, these dashed lines are drainage easements. So this is actually where drainage will be going right into this pond right there. So since I know that these are where the easements are going to be, that's where my low points are going to be. So that's a really good first step. That's my first low point right there. Typically when we're creating these road lows and highs, we're doing it a little bit before we actually do this grading plan. We're actually drafting a site plan in order to understand where the road lows and high points are, and we're doing iterations with the stormwater management model. All right, next up is what is the minimum side yard slope for a yard? So once we actually finish all of this road grading, then we'll set the lot grading. I always typically start with the road first, but we'll get there in a second. So what is the typical lot slope? So again, these lots need to drain. You're going to have a house that's built on this lot, so it needs to be able to drain in this side yard slope to the pond and then to the road, typically in the midpoint. When you see something like this, when you see the lot grade from right in the middle, it's typically called a type B lot. You know, that might just be a typical local thing, so just verify your municipality. But the high point's basically in the middle. Now, sometimes you can have high points in the back, which is what I believe we're going to do here in order to avoid any need for drainage easements and pipes between the side yards. If we could just pitch up all of these lots here on this western side, we can pitch the lots to the road. So what this looks like is a high point, you know, in the very back of the lot right there that drains towards the road. So we're going to set a high point here and drain towards the road. So where I was getting with that is I need to know the minimum side yard slope, and that minimum side yard slope is typically 1%. All right, the next one. What is the minimum and max cross slope of the road? Well, I already mentioned this. So this road right here in the center line is sloping away to the edge of pavement, right? Because our edge of pavement here is going to be collecting in a gutter that goes into
our curb inlets. Our typical slope that we use is 2%. There's a 2% slope right there on the cross slope. All right, we're almost there, guys, I promise. What is the max change in road slope before needing a vertical curve? This is really, really, really important. So when you're traveling across this road, let's say we're starting at this high point right here and we're going down the road to this low point, and then we're coming up, 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 and then we're going down again. Well, that creates a vertical difference of grades. So you can either get a crest or you can get a sag. There is a maximum delta that you can have between those slopes before you need what's called a vertical curve. Now, a vertical curve, all that does, it just smooths out your curve. Instead of creating just a pointed high point, you end up smoothing out that curve. Now, the maximum that we can have for this project is a delta of 1.2%. So we can't have more than 1.2% before needing a vertical curve. Now, as a bonus, I know a really, really smart engineer that figured out a way by using calculus to never have to use a vertical curve. You basically just find intermediate points and you have to set more grades, but we'll, with his permission and his honor, we will do a fun video with that, but you technically never need a vertical curve. All right, we are almost there. We got 2 more left, okay? What is the maximum driveway slope? You have to know this. Once we start getting a steeper road, let's say if our road grade starts varying by a lot, we really have to pay attention to the driveway slopes. Imagine you driving a really nice Porsche, the last thing you want is to hit a very steep driveway. And this relationship typically comes with the finished floor and how we're going to set that, the step down from the garage, and that step down of the garage in relation to this right-of-way grade. I like to just use 8% max, but again, you can get steeper if you want to. Last but not least, what is the max slope for open space areas? So after we kind of, grade the roads, grade the lots, and start verifying some of these things, we have to start understanding how we're tying into existing grade right here. And I've put these spot shots on for a reason. Guys, there we have it. Thank you for bearing with me with that. These are the basic building blocks for creating a grading plan. These are our rules. Now we're going to be using the minimum slopes to save on earthwork. Now, typically, the higher you send roads, the higher you go with slopes, the more fill that you need. So that's why we typically use our minimum slopes. Now, okay, cool, Griffin, we have all of these rules, but we haven't even graded yet. I want to get to the fun part. I know, everyone wants to get to the fun part. You can't skip over that detective exercise. If you are wrong on your slopes, you got to redo your grading plan. So we had to get 100% with that. So now, since we have all of our constraints, where do we start?
Hey, really quick, thank you for tuning in. Teaching is one of my biggest passions, and if you do find this channel helpful, please hit that like and subscribe button. It keeps me motivated to learn and teach more of you guys this content. All right, back to the video.
Now, like I mentioned before, we typically start with the road low points. So remember rule 1 that I said? There's a reason why it was number 1. So remember how I said earlier that typically we have to set the site plan and then we have to do the drainage model before we even begin grading. Well, the reason why we do that is because we have to have these grades first in order to set our road lows. Imagine if you're still doing drainage model iterations and all of these elevations change. That would be the worst. Now, one thing I forgot to put in here is the actual design high 25. And again, if you're not familiar with Design High 25, all it is a storm event. So we are running model iterations of a 25-year, 24-hour storm event. This is associated to an amount of rainfall and a rainfall curve. So there's a distribution here in this pond, and this is what causes that pond to stage up. And that pond staging is directly connected to our inlets that we're going to propose. So we can't flood the roads. Well, we can flood them to a certain aspect, but we are required by code to set those road lows at this particular elevation. Now, the design high 25 that we're going to use based on our model for the 25-year ended up staging 3.5 feet above the normal water level. So that means that our design high 25 was 52.25. And we had to have 1 foot of freeboard from our 25-year to the top of bank, which we do meet. So we needed 1 foot consider it just kind of insurance from that design high water level to the top of bank. So now we're actually able to cook with fire. So let's get right into grading, guys. This is the moment that you've all been waiting for. All right, let's go ahead and set the low points. So we know that these low points have to be a minimum half above the 25 year. So if that's the case, if the 25 year is 52.25, that puts this edge of pavement grade at 52.75. So that's how we get that math there. So let's start with our low points. So typically on a grading plan, you need a point on the center line and then the edge of pavement. So like I said earlier, since we're sloping up to the road center line or away from the center line, this is going to be a 0.24 drop. And if you wanted to do the math there, we can do 52.75 plus 0.02, because that's 2%, times the width of the lane, which is 12 feet wide in this case. Now for quick math, you can always multiply the lane width by 2 and move your decimal place over 2 times, but that's just some advanced math. Now, we did get an answer of 52.99. I really just like rounding. I like using whole numbers. That's just like a rule of thumb that I like to use, is typically in this thousandths place, it's so negligible because the contractor's not going to get it absolutely, to the nad's butt there. So the other side will actually be the same grade here. All right, so we're going to start with those road lows. So I'm going to take those same points because this is the lowest. I'm going to copy these guys and move them over to where this low point will be. I got to kind of line them up there. All right, so now we got our road lows. So now we have to understand the high points. But do you guys remember what I said about the minimum longitudinal slope? The minimum longitudinal slope from this low point to high point is 0.35%. So let's get out our little linear feet calculator here, our little tool. And let's see how long this road is from. There is a road cross slope here. So we're actually going up to here for our grade because this road cross slope, again, is 2%. We have to maintain this 2% right there. We need to carry it all the way up to the end of this lane. So let's go up from 53, which was our low, plus 187 times 0.0035. Don't forget the 2 zeros. We still get around 53.7. I like to just round. I like to use round numbers. So we're going to use 53.7. So we can add 0.24 to each of those cross slopes. So now we need to establish the high point in between these two low points, because right now we just have 2 low points. If the contractor were to grade this at 53 and go up here to 53, this is just going to be a completely flat spot. So this road needs to be pitched in order for water to be collected into these inlets and go into this pond here. So let's get the exact distance in between and let's just cut it in half. Looks like we got 270 right on the dot. That's kind of crazy. So let's do 270 divided by 2. So that high point can be placed 135 feet in between. So if we take this, let's try to find 135 feet. And a lot of times I like to have either a high and low right on a lot line. So I'm actually going to go kind of right there to that lot line. So we have to determine these high points. Again, these are high points that slope down to this low point. Now, since we split the difference between these lows, these are pretty much going to have the same slope. So this slope there to that low is going to be the same as that slope. Pretty dang close. So the minimum slope was what again? 0.35. So let's take 142 times 0.0035. We are going up about half a foot. And then what do we go down again? If we're going down on a cross slope, we go down 0.24. So 53.5 minus 0.24 is 53.26. 53.26. Now you can take it to 53.25, and I'll show you why. Because 0.25, let's do the math here. 0.25 divided by 12 is just a little bit more than 2%. It's 2.08%. In the grand scheme of things, it's not major. Guys, we are like pretty much cooking with fire. We almost got this portion of road mapped out. Now, the tricky part is going to be this cul-de-sac. We need to start thinking about this cul-de-sac. Now, when it comes to cul-de-sacs, I really just like to think about the gutter. The gutter is the absolute most important. I need water from this gutter to be pitched enough to work back into these inlets that are going to be placed there and there. And I know I've been saying this a lot, but if you're having a tough time visualizing, these are going to be little curb inlets here within those curbs, right? We're going to have structures. Of course, they'll be angled correctly, but these are going to be structures and pipes that ultimately carry water into this pond via a pipe there. So that's what's going on. And we're going to have one under the road here. So if you're having a tough time visualizing what's going on, that's how we're collecting water into our system. So we need to collect water from this cul-de-sac. The first place that I start is essentially going from this low point up to where this high point will be. Now, there's no particular rule of thumb of where to place this high point, but a really good spot, at least to me in my eyes, seems about right here. I want to cut the difference between the linear feet of this low point and the linear feet of that low point. You see how this low point has to make its way around these curves? Well, I don't want to set the high point right there because now I'm going to have to travel along more linear feet of curb. So I kind of want to just find a sweet spot. So that sweet spot is going to be around. So I need to find this grade, and I'm going to work backwards, and I'm going to see which one of these is the longest amount of linear feet. So I'm going to use my tool again. And don't you just love how you don't need CAD for this? I know I'm kind of taking a while, but this is really meant for beginners of grading, just to walk through every little thing that I'm looking at. You do not need AutoCAD Civil 3D to figure this stuff out. So that's 202. So that is a longer slope. So I actually want to set this high off this one. Because if I know I'm setting it off this one, this point's going to be higher and this slope is going to be greater, which is totally fine. But I need to make sure that I at least meet the minimum slope of the longer route. So let's go up from 52.75. We're going up from this curb line and around. We're going up in elevation, 0.0035%. 0.0035 feet per feet. And then I said there was 202 feet in between the two. So we're going to set this grade at 53.5. So we are getting water from that high point to there. But we're not done here with this cul-de-sac because we need to make sure that the contractor is building up this landscape island high enough in order to get water from this landscape island back to. Considering that this is just a 12-foot lane, what we can do is go up. What's the handy rule? 0.24. We're going to go up 0.24 because that's the 2% cross slope that we need to get water away from this island and into the curb. Now, sometimes engineers will set grades within the landscape island. I mean, the last thing I want this thing is to be a pool of water. So sometimes you can give a grade within here. Now, let's think about this though. There is a curb around here. The grade that we gave is the edge of pavement. That edge of pavement is going to be lower than the back of curb. Typically, that curb has about a half a foot elevation difference to it. And I'll show you pictures over here. Usually there's, an elevation to it. So we're going to have to go up at least on that back of curb grade, half a foot. So I'm going to go back of curb. I like labeling, the back of curb grade just to give the contractor, a direction here. And we're going to go 53.74. Now let's add half a foot. So it's going to be around 54.25. Now, if I want water sloping away or built up in this area, I'd either want one or 1 or 2%. Now, I don't really know how long this route is. It's about, let's call it 30 feet. So let's go 30 feet at 1% from that 5425. And again, all this is just going to be grassy landscape area. But the last thing we want is to have this elevation at like 51 or 52. Then it just creates a bowl of water. So who wants that? So we're going to go 54.25 plus 30 feet times 0.01 for 1%. And let's just call this grade 44.6. And let's visualize this, guys. This grade is higher than this grade. So water is going to be sloping away in this grassy area off of this island into the gutter. And either way, water's going to permeate into this area anyway. We're most likely not going to create a bowl of water, but for aesthetic reasons, you want to kind of build up this area. Now, one grade that I kind of want to review, and it's important sometimes, is I just want to make sure that we give the contractor enough points along here. Typically, when you give points, you give them on what's called the POC, or the point of curvature. So we'll typically give points all along these points of curvature. So I just want to verify a couple of these points. So we know that the slope remains constant from this low point all the way up to this high point, right? So technically, we could figure out the elevation of this point, and then we can relay it back to this point because we know that this is going to be a 2% cross slope. So let's just kind of verify what this grade would be and what this grade would be. That way we can verify what this island kind of looks like and the elevations associated. So I'm going to go ahead and copy this point, and I'm going to go roughly right there at that POC. That is a change in the curvature. So let's get a linear feet from this guy, and let's go all the way up to this point. So we got about 67 feet. Let's go up 0.35% at 67 feet. So I'm going to take that low point, 52.75, plus 67 times 0.0035, and I get 52.98. Do I want to round? I'm not going to round for this one. So that grade right there is going to be about 52.98. Even if I didn't give that grade there, it would be around 52.98 because the contractor and surveyor in the field is going to stake those grades out, the 52.75 and that 53.5. But we're just finding that intermediate point just to verify some of these grades here. So if I were to go up 2% there at that 12-foot lane, let's take the 52.98 and you get around 53.22. So you can kind of see this relationship here. You have an edge of pavement grade at 53.22, and then you have one over here that's almost half a foot higher, which is okay because the point is that no matter what, we just want this higher. This circle is built up higher to get stormwater to flow into the gutters there. But man, we are really, really close. Now, the very last part of all of this is to establish some of the right-of-way grades. Now, I think that's actually one of the easiest things that we can do. And I'm not going to sit here and do every single right-of-way grade because once you understand how to do a couple of these, you can do them all. So I just want to do a good stretch right here and then walk through how I'm kind of analyzing these lot grades. Let's walk through how we're actually setting the right-of-way grades. So in general, with this type of neighborhood, the rule of thumb is that this center line is going to be a very, very similar grade to this right-of-way line. Now, how do I even come up with that? Well, if we look at a cross section here, or the width between this center line and right-of-way is roughly 25 feet. So the midway point between this point here, between the center line and edge of pavement, is nearly the same as the edge of pavement to the right-of-way. And if we're going down 2% and then up 2%, that means that this right-of-way grade is going to be nearly identical to that center line. Now, if we wanted to be technical here, let's kind of work out how I'm actually thinking about this right-of-way grade just to prove to you. So if this right-of-way grade is 53 and we're sloping down 2% to this edge of pavement grade, this curb right here is actually a Miami curb that we're proposing. Miami curb is a typical Florida curb, which is 2 inches higher on the back side of the curb. So if we're going up 2 inches higher from this edge of pavement point to this point, let's just document it. You don't have to put this point on the grade, on your grading plan, by the way. but just for the heck of it, we're going to show you what I'm talking about. So let's do 52.75 plus 2 inches. I'm getting 52.92. That's correct. 52.92. 52.92. From that point all the way up to that right of way, I'm sloping 2% again. So we're barely going up, you know, from that point up to that point, which let's call it 11 feet. That's 11 feet left. So if I do 52.92 plus 11 feet times 2%, you get about 53.14. Now, we're lucky we had Miami curb right there, because that 2 inches actually brought this up a little bit. Notice how I said this center line is roughly the right-of-way grade. If we were to use valley gutter, where this curb isn't higher on that backside, then we would get roughly 53, or maybe like a 53.01, which is so negligible. Now, one of the reasons why we might want to have this right-of-way grade a little bit higher than this center line, at least for this right-of-way width, is to pitch water away to the street. Sometimes what can happen is this sidewalk can be built low, and then water pools up into the sidewalk, and it can actually get into this open space strip right here and into the road. So since we know this relationship, guys, all of these right-of-way grades become really, really easy. We know that this right-of-way grade will be 0.14 higher than this center line. So I can literally take that same grade right there and go up to my other low point and start setting that right-of-way grade. And keep in mind that right-of-way grade is also the property line elevation at that point, because that right-of-way is the start of someone's yard, of someone's side yard. So I'm not going to take the time and do every single lot line elevation, but I am going to go up from this low point up to the high point just to show you guys how to start setting these lot grades. And this is actually one of the easiest parts of this exercise. So again, guys, you do not have to set any more road grades. I'm going to set road grades just to show you how I'm setting this lot line grade. In your plans, this is sufficient. You don't even need to show this curb line anymore. So I'm going to delete that. All you have to show is the center line, edge of pavement, and then each of these lot endpoints. So the next step that I'm looking at is how do I set all of these lot grades right there? So we know that this road and this right-of-way is all going up at 0.35%. Since it remains constant, these grades are going to remain constant as well. So the easiest way to do this, guys, is to understand what this width is. It's 60 feet. We can take this grade and do 60 feet times 0.35%. It's as easy as that. So we're going up 0.21. We're going up 0.21. Now you can keep doing this with your calculator, which will take you a lot of time, or you can just add 0.21 to each of these lots. But I feel like this is the easiest way. You're just adding 0.21 here. So 53.35 plus 0.21, 53. And this is, where rounding can kind of come in. In this case, I'd probably use the 5360. So this was pretty easy setting that right point, but notice how this left area, we don't have perfectly aligned low points with the side yards. So we have to start understanding what this relationship looks like from this low point to this point. I hope that makes sense. Again, this low point aligns directly with this lot line, but this one doesn't. So it won't be the same exact elevation, right? Right here would be more of a 53.14, which I'll put there. We won't show this on the grading plan, but this is for reference. This grade is going to be about roughly 53.14. But what's this grade? Well, let's think about this. If this is a low point and we're going up to that point at 0.35%, well, we're taking this point right here and going up 0.35%. Now, I know it's such a minuscule difference here, but we want to be technically right when they're actually staking all this out and grading. So that's about 9 feet that we're going up. So let's take our 53.14 plus 9 feet times 0.35. 0.0035%. Now this grade is going to be roughly 53.17. So since that's the 53.17, do you remember our rule of thumb? Every 60 feet at 0.35% is an increase of 0.21. So let's go ahead and take this grade and let's add 0.21 to it. And yeah, I I like rounding. We're gonna be exact here. So 59. So with that one, I'll do 60. Now, another way you can do this is you can just use the road. So you can calculate whatever this is and then go up. So let me just show you guys that really quick. So we're gonna go to this point. So that was about 58, 8 inches. 8 inches is about 0.67. So let's go 53 plus 58.67 times 0.0035. So that road grade here is like 53.2. And again, you do not have to put this on the plans. You're just creating more points for the contractor, which are unnecessary, but just for calculation's sake, let's look at it. Now, it looks like we didn't get absolutely perfect because if you remember the relationship right here between road centerline and right-of-way, it's about a 0.14 differential. Now, it doesn't even look like we have a 0.14 differential right here. It's more like a 0.18. But in the grand scheme of things, it's really not even that big of a deal, and I'll show you why. So here we're sloping down 2%. Let's do 53.2 minus 0.24. And it probably had to do with rounding. And also, if you gave this plan to many different engineers, they'll come out with different grades. So that's the edge of pavement grade. If we get the back of curb grade, the back of curb grade is going to be around 2 inches higher. So let's add 2 inches to that, 53.13. And if we were to go 2% up to that right-of-way grade, let's do 53.1. 53.32. So that's that difference there. So we just back checked our math and got 53.32. So this top one right here, I'm going to change this to a different color. Let's say blue. This was us working our math from this road low up to, along that slope, down, curb, up to 53.32, which is still, it's not wrong. I'm just showing you different ways to do it. I mean, what is this? 0.06 in the grand scheme of things? That's like a little over half an inch. A contractor can go put their boot and step on that dirt and squish it by that much. So in the grand scheme of things, I'm just showing you different ways in order to calculate these grades. I kind of want to go with the higher one because like I said, I want to give some flexibility for water to actually go into those curb inlets right there. So since I'm okay with that 53.3A, I can place that grade right over here. I mean, those are going to be similar grades. And I can take this grade, put it right there, 53.6. Now what I'm going to do is analyze what these mid-lot grades should be and how that relates to our pond top of bank, and then we're pretty much done, guys. Like everywhere else is just math, and I believe that you can do it. All you have to do is know your constraints. So let's finish out these lots and then slope to the top of bank. So let's go ahead and just take a few of these points here and start setting this grade here. So we know that it has to be 53.3. So we need to make that known that 53.3 grade, this top of bank line, so that's just one of our constraints here. Now, one constraint that I didn't really talk about is that we have a max slope between this pond top of bank to the normal water of 4:1. So what actually is this slope right now? This top of bank is at 53.3 minus 48.75. That's a 4.55 feet of drop between these points. So let's see how much distance that is. So that's 20 feet. So 4.55 divided by 20. Yeah, it's about 22%. So we have a little bit of flexibility if we really wanted to increase these points. If we wanted to, if we had to. It doesn't look like we'll need to here. So I'll kind of get to that in a second. So let's start with some of these lot midpoints. So again, let's see how deep these lots are. So from this point to that point, it's 120. So that means right in the middle is 60. And that's where we're going to have a high point. Now let's think about this here. If we need to have minimum 1% side yard slope, meaning from this high point to there and then to there, well, what grade do you think is going to govern this high point? It would be the highest between these two. Because if I set 1% from this point up to here, well, I know for a fact it's not going to be 1% from here to there because this point's higher. So I'm going to start understanding which one is higher between these two, and it is this one. So let's do 53.3 plus 60 times 0.01. So we get 53.9. So that point right there has to be 53.9 to meet the minimums. And I can just go ahead and keep setting these grades. I mean, 0.05 in the grand scheme of things is not due as add 0.05 to it. So we can round this and we can call this 54. But now as we're going up the road, notice how we start warping a little bit. This road's getting higher in elevation while the pond, top of bank, or the back of lot is just staying the same. Again, higher, staying the same. So we're getting a little bit of warp here. One thing to kind of be cautious about. So now this point is actually higher than our back of lot. So we're gonna have to use this grade to set the midpoint. And again, I like rules of thumbs here. If we're doing 60 at 1%, we're going up 0.6. Let's make math easy on us. So if we're going up 0.6, that means that this grade is going to be 54.2. Always do some easy math here. And guys, that's how you keep setting these grades. I'm not doing any sort of magic here. This is how I would continue to set some of these grades. Now, I think where I'll finish up here is this area because I'm really interested in how we're going to get water into this pond. So let's kind of figure out what's going on. If I know that this pond is going to be all at grade 53.3, I need to make sure that these grades are higher right here to transport water into this top of bank. So if that's the case, I'm going to take up my minimum grade here and go up 0.6. And just in order for rounding sake, I'm going to do 54. Again, I'm going up 0.6 and then going down 0.6. So where does that put us if we're going down 0.6? 53.4, which is actually perfect because this grade is higher than this grade. So water can pitch back to that top of bank. So let's keep moving here. So this is going to be 54.2. Then I'm going to go down. And these grades are going to be similar since this is the midpoint. So this point will be the same as this, 53.6, because I'm going up 0.6, down 0.6. And notice this grade is higher than this. So water is doing what we want it to do. This can serve as our break point for water to go here and then to go down to the pond. All of this right here. And you can even form a little swale if you wanted right there. Guys, I mean, we're really creeping up on time here. I'm pretty much done with this exercise. Again, a lot of grading is just setting the constraints, and then it becomes just a game of easy math that you learned in 8th grade. So I hope you guys learned something new. I appreciate everyone tuning in. I hope you now have become a grading expert. You'll always have this resource if you are ever stuck again. I will also continue to make more videos where we see some interesting grade changes. And I've even included a free PDF in the link in the description to give you guys a chance to grade this by hand yourselves. Just keep in mind, there can be 100 different solutions depending on what types of slopes you want to use. In this case, we were using the absolute minimum slopes required by the county. But that's all I have for today, guys. Hope you guys learned something new, and I will see you in the next video. Thank you.